Welcome to CS1203 Database Systems 1. This is the Unit 6 lecture part 1. During this particular lecture, we're going to kind of go through and do a bit of an overview of the different data types that we would be dealing with, managing within SQL. Now, if you recall in some of the previous units, we've kind of gone through and we've defined relations, and one of the things that I've asked you to do in those relations is to kind of identify for each of the attributes what the data type is. And if you recall, we kind of said, hey, let's not be too specific about it right now, just kind of identify in general what the data is and what it might require in terms of formatting rules and validation rules. But we didn't get into a lot of detail around very specific data types. What I'd like to do today is just provide a brief overview of what some of the supported data types are within ANSI SQL, and in particular what is supported in ANSI SQL 92 and ANSI SQL 2008. And what we're going to do is just look at kind of supported data types, not distinguish between the two. Now, kind of getting into that, I just want to kind of cover a few of the different categories of data types. So we have 4 or 5 different major categories of data types, one of which is the numeric data types. So this is basically all of the different data types we can use to maintain and store numbers or numeric values. And there are 2 essential types that we have out there. One of them is integers. So if you think about and remember back that an integer is the set of counting numbers. These are whole numbers. They can be positive or negative. They just don't have any fractional components in them. And one of the things we learn when we start learning about programming is that when we start looking at integers, the larger the number is, the more space it requires to store that number. So I have different kinds of integers based upon how large the number needs to be. And we can see some of the examples that we have down here where we have everything from, and just kind of mark this here, where our integer values are. And again, whole numbers and different sizes. So, kind of we go everything from a tiny int, which by the way is essentially 1 byte in size, on up into a very large integer up here that would actually be several bytes in size. And if you want to kind of figure out what those sizes are and what they need to be, you can kind of think about it just from the perspective of what the largest number is you can have in binary in terms of the number of digits out there. So for example, a binary number that is 2 to the 32, or actually 2 to the 64 or 64 bits, would allow us to maintain a very large integer, which is minus 2 to the 63 through 2 to the 63rd power minus 1. And essentially the reason why it's 63rd is that the final bit that's out there is actually used just to sign it. So all of these numbers you can kind of see come based upon the size of the integer in terms of the number of bytes that are maintained within it. And again, the only thing we really need to know is we will select one of these integer values when I need to maintain an integer based upon the size of number that we're going to need to be able to maintain. Now, there's another group of numeric data types that we want to kind of look at, and those involve numbers that have a decimal point in them, or they're a floating point number, or something that is not a whole number. It has fractional components of it, and there are a number of different mechanisms we can use. One of them is the decimal, and what's really neat about the decimal is that this is a very useful data type when we want to use and be able to store values of currency, because the way it's specified is that I give a length value. So let's say I want this to be 10. That means the total size of the number has 10 digits in it, and then I can put a comma, and then I put the precision. So if I put a precision of 2, that means that I can have a number that is 10 digits in total length, 2 of which exist to the right of the decimal point. So that would be essentially, if you think about it, a number that would have something like this. and this is where our commas would go for place settings. So this number, or the largest number that would fit in this, which would be, by the way, 99,999,999.99, which, by the way, is 99,999,999.99. That would be the largest number that we can actually fit into this particular decimal value, because it's 10 total digits, 2 of which exist to the right of the decimal point. So that kind of gives you a whole idea of that precision and how it works. We also have a more generic data type called numeric, and then float, real, and double. And so this is just very basic floating point numbers. And the precision and the data is maintained based upon the size. Again, very similar to what we have with the integers. Real, float, double specifies larger numbers that we can maintain that are floating point based, and real being the smallest and double being the largest. So let's kind of move on and look at the next data type, which is going to be all the character-based data. So when I start talking about characters, it means that I am not dealing with just numbers anymore. I'm dealing with character strings, or things such as names and addresses, things where I might have a mixture between alphanumeric characters or numbers that exist out there. And there's a number of different types that we have out there. Basic ones are things like character and char. What you see here is that they always have a specification on them, and the specification tells me how many characters. So, for example, both of these data types here, the char and the character data type, would allow me to store a string that was up to 10 characters, 10 alphanumeric characters total in size. Another one I want to kind of point out here is this varchar. And the var at the beginning of it means variable. So what is unique about the varchar is that in a char, where I'm specifying the size to be 10, it means that we're always going to use 10 characters of storage space to store this particular attribute value, regardless of what I put into the value. Varchar, on the other hand, is a variable sized string. So, for example, if I put only one character in to this particular varchar specification that says the maximum size can be up to 2 characters, then I'm only going to use 1 character of space. Same thing goes if I were to make this varchar, and in the parentheses, if I were to put in, let's say, 50 or 60 characters for an individual's name, that would allow me to accommodate very long names up to 50 or 60 characters, and relatively short names as well, without wasting a lot of space. Some of the items you have down here are designed to deal with very large groups of characters. So, for example, a character lob. Essentially, what these values are for is for defining very large text spaces within an attribute field. So, for example, if I had a database system that I was trying to maintain books, and the content of those books was entirely textual based, I could in fact define a very large character string data type and store the entire book or document in textual form within it. So, if the only thing that was in that book or that document were in fact text characters, then I could just store the whole thing in there. This is where you can see very easily how a data type such as the character large object could be used in that way, because we're specifying that I can have up to 1 million characters in there. 1 million characters is more than sufficient in many cases to store an entire document, a large document, or a novel. So you can get a sense for how some of these character values are used. And again, we use all of these types of character values when we have data that happens to be textual, that it's a mix of alphanumeric values. So it's not just numeric, not necessarily just alphabetic, but alphanumeric, and we can store them in there. Again, big points: when it tends to be fixed in size, I would use char or character. When it tends to potentially be variable in size, like an address or a name, I'm going to want to use varchar. And I can use these blob data values when I'm trying to store a very, very large amount of text. Let's kind of look at a few other ones. Boolean type, and think of a Boolean as essentially a on, off, yes, no. So essentially Boolean type is a way of storing a bit, and essentially that type would have 1 bit. We also have a series of other binary types where I can store binary numbers. And again, think about it in this context. Everything I'm putting in here, it's assumed to be bits. So in this particular case where I'm using binary and we're saying binary and the precision is 10, that means I have a binary number that is up to 10 digits in length. So for example, if I wanted to store that particular binary number, I would use a specification of binary of 10 because this particular number has 10 binary digits in it. And again, same kind of a thing where I have blobs, where I can use very large numbers or very large binary values. And in also the var preceding any at the beginning of an attribute generally indicates that it is a variable size. So for example, in these particular character data types would be useful whenever I don't know exactly, or when the size of the binary object that I'm trying to keep happens to be variable. Where some of this stuff becomes useful is that many times there are objects such as graphics files and things of that nature that might actually be stored in a binary representation, and I can use these kinds of data types to maintain them. Moving along, we're going to look at the last group of things that we're going to look at. We obviously have some bit types. We're not going to cover that in a lot of detail. And then we want to look at the date time types. And this is something we're going to kind of come back to because dates are a very interesting thing to maintain within the database because we're not just having a simple date. Most of the time, the way that dates are being stored in the database is it's kind of an elapsed time from a point that they refer to as the epoch, which was some date back in the 1970s. And essentially what the format is it keeps track of the number of seconds that has elapsed since the epoch. So what's actually being stored in here is the number of seconds that has elapsed since the point of the epoch. If you want to find out when the epoch actually occurred, you can go look it up. Wikipedia will have it out there. And because I have all the number of seconds, what I'm keeping track of is the number of elapsed seconds, I can extract from that a specific date or a specific time or time stamp. So that gives me a reference point of time, and then I can actually adjust that time based upon a time zone. So we have that intelligence to know that I can add to or detract from that basic value to determine what that specific time is in different time zones around the world. But again, key things I want you to understand here is the way that we're keeping track of dates and times, and the fact that it's generally going to be stored as a number representation, that is the number of seconds that have elapsed since the epoch. And that because we're doing that, a lot of times we have to do some things in terms of conversions of dates so that we can make the system understand what type of date we're providing it, such that the system is then able to convert that date specification that we give it into something that it can maintain internally, which again is going to be a elapsed time since the epoch.